Page 13, Synthetic Division. This shortcut method for dividing polynomials can only be used if you're dividing special linear factors. A special linear factor are factors of the form a x to the r minus c, where a is 1 and r is 1. And c is any constant real number. Now you could use another number for a. You would just have to have a fraction inside of this box. The remainder will be the numerator over the divisor. The quotient will always be 1 less than the degree you started with. Here's our examples. Example 1, we have x squared plus 3x plus 2 all over x plus 1. So to find this number in here, it's going to be the 0 of the denominator. So we're going to set x plus 1 equal to 0, subtract 1 from each side, x equals negative 1. So we're going to put negative 1 in the box right here. Now in this first row, we're going to put the coefficients of the numerator. We have 1x squared, 3x's, and 2 constants. We break down the first number, 1. To get the next number right here, we multiply that 0 of the denominator times 1. It's negative 1, we get 2. 2 times negative 1 is negative 2. And so you have a remainder of 0. So your answer is 1x plus 2. Since the remainder is 0, we do not have an oblique asymptote. Instead, we have a whole at x equals negative 1. If we did have an oblique asymptote here, this number right here would be a vertical asymptote. Let's look at the next example. Example 2, x cubed plus 2x squared minus 3x plus 12 divided by x minus 1. Well, we're going to set x minus 1 equal to 0, add 1, x equals 1. So that's what goes in the box. We're going to write the coefficients at the top. So there's 1x cubed, 2x squared, negative 3x's, and 12 constants. Break down the first coefficient. We have 1. 1 times 1 is 1. So we add those together and we get 3. 3 times 1 is 3. You get 0. 0 times 1 is 0. So we have a remainder of 12. So that means that this number is a vertical asymptote. And this number right here was a whole. So our answer is, we have 12 remainders, 0 constants, 3 x's, and 1x squared. So we have 1x squared plus 3 x's plus our remainder, which is 12 over our divisor, x minus 1. Your oblique asymptote is this part without the remainder. So it's y equals x squared plus 3x. And let's look at the third example on this page. Example 3, we have x to the 4th power minus x plus 2 all over x minus 2. So we're going to set the divisor equal to 0, add 2, x equals 2. So that's what's going to go in this box. Now, there's some things that we're leaving out here. We don't have a cube and we don't have a square, so we're going to have to put plus 0x cubed plus 0x squared in between. So let's write all 5 of those numbers. So we have 1x to the 4th, 0x cubes, 0x squareds, negative 1 x's, and 2 constants. Break down the first number. 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4. 0 plus 4 is 4. 4 times 2 is 8. Negative 1 plus 8 is 7. 7 times 2 is 14. And 2 plus 14 is 16. So we have 16 remainders. We have 7 constants, 4 x's, 2x squareds, and 1x cubed. So your answer is 1x cubed plus 2x squared plus 4x plus 7 constants plus our remainder 16 over x minus 2. It has a remainder that's not 0, so it has an oblique asymptote at y equals this expression without the remainder. So remember the two cases. When the remainder equals 0, the divisor is a whole. And there's no oblique asymptote. And then case 2, when the remainder is not 0, the divisor makes a vertical asymptote. And the quotient equals y is the oblique asymptote.